two different ways to categorize how we determine probability. Let's start with the definitions just so that we can recognize the difference between these two.
Don't we already have experimental though?
We have probability, we don't, and we have experiment, but we don't have experimental probability. So experimental probability is based on, what do you think? Doing an experiment, literally on the results of an experiment. So like we saw in that example that we did from the homework, the tally marks show the experimental probability. That is the results of our experiment. We would use the tally marks to give the experimental probability because it's based on the results, the repeated trials of that experiment, of flipping that number cube. We write it like this, and we'll do this more when we get to the examples. The probability of an event. So like going back to the number cube. If we're going back to that example that we were working through on the board, we were looking for the probability that you rolled an even number. So in the parentheses, you put that favorable outcome that you're looking for. Probability of an even number. And if we think back to that problem, the probability based on the experiment is the number of times that event occurs. So remember on the chart, how many times did it occur that we rolled an even?
I think it was 26.
26, right? Good. 26 times out of a total of 50 rolls. That was our experimental probability based on literally the amount of times that we rolled that dice. Okay? Versus, so not versus, we're actually going to do an example. Okay, let's look at this. You flip a coin 25 times. The results are below. So it looks like out of 25 times, 6 times it landed on heads, 19 times it landed on tails. You can. Here's what it asks. What is the experimental probability? So watching carefully for what they're asking for is important. Experimental probability means it is based solely on the results of the experiment. So the experimental probability of flipping heads, we would write it like this. The probability, and what is our favorable outcome that we're looking for?
Heads.
Heads, because that's what they're asking us for. Probability of flipping heads on the coin is the number of times it happened, which is what?
25 times.
No. How many times did our
Six.
favorable outcome? Yep. 6. Out of the total number of times we flipped the coin. 25. So that's how we write this. The probability of that favorable outcome that we are looking for, which is flipping heads, is written as the number of times that it happened in the experiment over the number of total times we did the trials. Nope. You literally can leave it just like this.
Oh, I figured it out.
You can leave it just like... So now here's my verses. Theoretical probability is slightly different. But theoretical probability is what you predict would happen. So if you are going to flip a coin, what would you predict would happen? How many times out of, say, 10 do you think you would flip a heads? Kellen? 5, right? Because 1 and 1, you have 1 on each side, right? 1 out of 2 sides is heads, 1 out of 2 sides is tails. So you would expect that 50% of the time, theoretically, without doing the experiment, that's what you would expect. You predict based on the total number of outcomes as compared to the number of possible events. All right, so for example, or not for example, but we write it the same way. The probability of the event, so the probability of flipping heads, getting an even, getting an odd, is the number of favorable outcomes that you're looking for over the total number of possible outcomes. So here's example 2. It says you randomly choose one of the letters shown. What is the theoretical probability of choosing a vowel? This is basically what we were doing yesterday. Theoretical probability of choosing a vowel. So what are the vowels in here? Noah? Yep. Yep. Okay, yeah. Okay, so there are 3 vowels out of a total of 1, 2, 3, 4, 5, 6, 7 letters. So the theoretical probability, we write like this. Probability of, what are we looking for? Vowels. So we write what we're looking for. Probability of choosing a vowel would be 3, because there's 3 vowels, over 7 total. Exactly. And that's the answer. That is the answer.
That's so easy.
Example 3. All right, you roll a number cube 300 times. So again, number cube just means a 6-sided dice.
Bro has no way.
No kidding. What is the theoretical probability of rolling an odd number? So first, think about a number cube. How many total sides are there?
Oh, 6.
6. And how many of those numbers are odd?
3.
3. 1, 3, and 5. So there are 3 out of 6, or simplified, 1 out of every 2 rolls you would expect to roll an odd number.
Or
Let's apply that to 300. What's 1/2 of 300? Because we would expect that 1/2 the time. Kellen, what would we get?
150.
Good.
Yeah.
So we would expect that 150
Over 3.
out of 300 times you would roll an odd number. Now,
Can we just do the math?
yes. One thing I will caution you on the homework, make sure that you read carefully how they want you to input the answer. So do they just want 150? Do they want it to be 150 over 300, or do they actually want it simplified in the fraction? So just be careful with how you input your answer. Yes.
How do you know just to leave it as 1/2 or to do it?
Well, you get 4 checks. So what I would say is that's part of the reason that I give you 4 checks. If you put in 1/2 and it's not right, try putting in 150 over 300. Okay. Typically simplify the fraction, though. I'd always go with a simplified fraction to be safe. Oh, gosh. Hold on. I'm going to just erase this part so that we can look at the second question. Now, this is what's going to happen here. Now, here's the results of your actual experiment. So you rolled this number cube. So here's what we predicted. I'll put this back up. We expected that 150 out of 300 times, based on theoretical probability, that you would roll an odd number. Well, then you rolled that number cube 300 times, and this is what actually happened. So we rolled a 1 48 times. We rolled a 3 50 times. And we rolled a 5 49 times. So this would be experimental probability. Why? Why is this experimental and not theoretical? Kellen?
That's what happened in the experiment.
Yeah, it's what actually happened in the experiment. All right, so let's write this. The probability of rolling an odd based on the experiment would be what? We need to add 48 plus 50 plus 49. What do we get?
147?
Yep.
Dang, I don't know how
Good job. 147 out of 300 times. So it's close, right? And sometimes that's what happens when you do the experiment. It doesn't always happen exactly as you predicted. It's pretty close to 50-50, but it's not exactly but we have to go with how it actually happened. Like, that's how it was rolled, and that's what we would put in for the experimental probability. Slightly different from theoretical. Oh, goodness. Okay. Shh. You don't need to write this, but this is just good to know. The more trials you do results in the experimental probability getting closer to the theoretical probability. So, like, if you only flip a coin one time, right, it's going to give you a different experimental probability than if you flip it 100 times, you're going to get closer, or 1,000,000 times. So the more you repeat an experiment, the closer you'll get to what you predicted would be the theoretical outcome. Okay, let's see what else we've got here. Let's look at this one. It says a bag contains 50 marbles. Whoops. You pick a marble, record the color, put it back in the bag. The table shows your results, so our little table down here, after 30 picks. So we know this is a total of 30 picks. Okay? So we're going to use this data to figure out some probability. Predict, whoops. Predict the number of red marbles in the bag. How can we set this up to predict the number of red marbles in the bag? This is going to be similar to what we were doing yesterday. Finn, tell me.
9 over 30.
Good. So let's start with 9 over 30, because that's from our experiment. We picked 9 red marbles out of 30 total picks. What would we set this equal to? What would we set this equal to? To what? To figure out how many red would be picked out of 50. What would we say? Anyone else? Yes.
X.
Yes.
50.
X over 50. We need to figure out what that number would be out of 50. To solve, what do we do?
9 times 50, and then 30 times X.
Yeah. Cross multiply.
30X.
30x equals 9 times 5 is 450. So x equals what? Nicholas? 15. So we would expect out of 50 draws, 15 times we'd have a red marble. Good. Okay, last one. All right, so you're spinning a prize wheel. You know those big things, and you spin them, and it lands on something, and then you win. The probability of winning a bobblehead is 1 in 6. The wheel has 18 sections. Okay? The wheel has 18 sections. 1 in 6 times, it's a bobblehead. How many sections then have a bobblehead? Caroline, what do you think? 3. How did you find 3?
Because 18 divided by 6 is
Good. 18 divided by 6 is 3, so 3 sections out of the 18 would give us 1/6.
You also do times 1/6 times 3.
Correct. You could also do 1/6 times 18, right? 1/6 of 18, exactly, would give us 3. Now, if you spin the wheel 540 times, why? I don't know, but let's say you were like at a carnival and you had people coming through. How many bobbleheads would you have to sort of have ready for people if they win 1/6 of the time? How would we figure this out? What would you do?
90.
What would you do? Bridget, what would you do?
Divide 540 by 18.
540, but we want to know not just how many different sections there are. What should we do? We want to know specifically how many bobbleheads you would. How much of the time do you get a bobblehead?
3 divided by 3. 40 divided by 3. Times my birthday. 1/6.
Okay, so I think the debate here is which number do we need here?
3. 3 over 8.
How much of the time do you win a bobblehead?
You do 3 over 18.
Which is what?
Over 6. Cross multiply.
Sure.
5, 6, 4.
Okay, so do you hear what Lily's saying? She's saying this. 3 over 18 times you win a bobblehead. Or, what is that?
1/6.
1/6 of the time you win a bobblehead. So what should we do with this 540 and that information? Caroline?
Put 1/6
Yep.
and then x over 540
Yeah.
cross.
Yes. Do you guys see that? 1 out of 6 times you win a bobblehead. How many times out of 540 do you win a bobblehead? Well, if we do our cross multiplication,
90. Yes, I was right.
yes, x equals 90 bobbleheads.
So you got to give out 90 bobbleheads.
It's not bad.
But that is experience. Is that?
Okay.
That's theoretical.
So that's theoretical.
That's a good question. Is that experimental or
It's
theoretical?
theoretical.
It's theoretical because has it happened? No. But if you worked at the carnival and 540 people came, you could document
Hypothetically.
exactly how many people.
Speaking.